New page, next question. So question 4. For a, we have k to the power of x over k to the power of 2. And this is a fraction of powers with the same base. So we can just subtract the exponents here. So that's going to be k to the power of x minus 2. For b, in this case, we have 11 to the power of r multiplied. Please don't write these crosses even though the book does. This is a multiplication symbol. 11 to the minus 4. And it's a product of powers with the same base. So we can just add the exponents. So this is 11 to the sum of r and minus 4. That is r minus 4. For c, in this case, we have 9 multiplied with 3 to the power of b, and, well, it's tempting to just say this is as nice as it gets, but we could realize that 9 is 3 to the power of 2. So we have 3 to the power of 2 multiplied with 3 to the power of b, and then we have two powers with the same base, so we can add the exponents. That's 3 to the power of 2 plus b. Alright, let's do 5. We have to write some expressions without fractions. So 1 over 11, of course, is just the reciprocal of 11, and it's the same as 11 to the power of minus 1. 5b, a over b squared is the same as a multiplied with b squared reciprocal. That's actually what division is. You multiply with the reciprocal, and then we can multiply the powers, because this is subsequent powers. So we can multiply the exponents, and that becomes a multiplied with b to the minus 2. That's what a negative exponent means. 5c, we have j times k to the 4th divided by L to the power of A. And that's a mess, because there's not really anything here that's the same, but what we can do is say we don't want to divide by L to the power of A, we want to multiply. So j times k to the 4th, then we just want to multiply with L to the power of minus A. And that's all we can do about this, because we have no idea if there's any relationship between any of the letters here. So that's it. Question 6. A. This time we have to express in exponent form with a prime number base. So 1 over 16 is, of course, 16 to the minus 1. That's just the reciprocal, but that's not a prime number. Actually, 16 is 2 to the power of 4, as far as I remember. It's 4 times 4 to the minus 1, so this is 2 to the minus 4. 6b, we have 3 to the power of k multiplied with 81. And we recognize 81 as the square of 9, or, since 9 is the square of 3, we have 3 to the power of 4. And then we have 2 powers of 3, where we can add the exponents, so it's going to be 3 to the power of k plus 4. 6c. We have a fraction, 125 to the power of a divided by 5 to the power of b. So we don't have the same base, and we don't have the same exponent, and we are sort of a little bit hopeless here. But what we can do is first say it's 125 times a multiplied with 5 to the power of minus b. That gets rid of the fraction. However, 125 turns out to be 5 to the power of 3. So we have 5 to the power of 3 to the power of a multiplied with 5 to the minus b. And here we have subsequent powers, so we can multiply the exponents. So this is 5 raised to 3a multiplied with 5 to minus b, and then we have the same base, so we can add the exponents. That's 5 to 3a minus b. Hooray! Question 7. So 7a, we have to write in what they call the simplest rational form. So rational form means that it's a fraction. So this time we work the other way around. So 2 to the minus 3 that's the same as 1 over 2 to the 3. And I'm not really sure what they mean by simplest, but I know that 2 to the 3 is 8, so I'm guessing they want 1 over 8. 7b, I'm not going to spend any time on, since everything to the power of 0 is just the number 1, and can't get any simpler than that. 7c is 3 to the minus 1, that's 1 over 3, plus 3 to the 1, that's 3. And if we want to do one fraction, we can say this is 9 over 3, so altogether we have 10 over 3. And that's a lovely rational number. In question 8, we want to express in simplest form without any brackets. For instance, we have this nightmare, 2 times a to the power of 6 over 8 times b squared, and all of this to the power of 3. So, getting rid of the bracket, we can raise both the numerator and the denominator to the power of 3. A product raised to the power of 3 we do by raising each factor to the power of 3. So 2 to the power of 3 is going to be 8 multiplied with 8 to the 6 to the power of 3 is subsequent powers, so it's going to be a to the power of 6 times 3. That's a to the 18th. Divided by 8 to the power of 3, that is 8 times 64. I have no idea what that is. 8 times 64 is 512 times b squared to the power of 3 subsequent powers. We can multiply the exponents. That's b to the power of 6. And I can see I could have saved myself some trouble here, because one of the multiplications by 8 cancels out with the 8 up here. So we could divide by 8 in both numerator and in the denominator, and that takes us back to 64 times b to the power of 6. And I'm guessing this is as simple as it gets. AB. We have 5d multiplied with d to the minus 5 squared. First of all, this is d to the power of 1, this is d to the power of minus 5. I can add the powers, so it's actually 5 times d to the minus 4. And I want that squared. Squaring a product can be done by squaring both factors. So 5 squared is 25, multiplied with subsequent powers, d to the minus 4 to the power of 2. I can multiply the exponents, so that is d to the minus 8. Whether this is the simplest form, or we want to write that's 25 divided by d to the power of 8, I don't really know. Both are lovely and simple. 8c, we have the fraction 16z squared multiplied by z to the power of 5 and divided by 2z to the power of 3. That's a lot of z's. So first of all, up here we have 16 times z to the power of 7. I can add the exponents because they are multiplied, same base. 2z cubed, I can put the power of the exponent 3 on both factors, so 2 to the power of 3, that's 8, and z to the power of 3 is of course just z to the power of 3. These 16 divided by 8 become 2, and z to the power of 7 divided by z to the power of 3, I can subtract the exponents. I can subtract 3 from 7, that's going to be z to the power of 4. There was a multiplication right there.